Good morning, students. I am Vijay Kumar. In the last class, we have seen the magnetic dipole concept. What do you mean by the magnetic dipole? Magnetic dipole is nothing but it is having the equal magnitude and having the opposite nature. That means it has two ends, that is north pole as well as the south pole. Those ends which we call it as the pole strength. And distance between the two poles, which we call it as the magnetic length, how much it is? 2 times L. So next we shall see the magnetic dipole moment. Magnetic dipole we have seen, now we shall see the magnetic dipole moment. So again I will consider the magnetic dipole bar magnet having the south and it is our north. Okay, these are the pole strength of the bar magnet, and distance between these is the magnetic length. We call this 2 times L. So how are you going to define this magnetic dipole moment? Generally, what do you mean by the magnetic dipole moment? Magnetic dipole moment which represents the strength of the magnetic field. Okay, therefore mathematically if I write, it is the magnetic dipole moment is represented by the letter capital M, that is capital M times, that is our pole strength and the magnetic length. Mathematically identifying the magnetic dipole moment as the product of the pole strength and the magnetic length of the material, which gives the magnetic dipole moment. So in case of the magnetic dipole moment, just I write down the definition. The magnetic. So, as I told you, mathematically, the magnetic dipole moment, it is the product of the strength of the either pole, or else just a pole strength, and the magnetic length. That is what? This is our magnetic length of the magnet. That means this is our magnetic dipole moment. And what is the magnetic dipole moment? Whether it is a vector quantity or a scalar quantity. Actually, the magnetic dipole moment is vector quantity because it tells us the magnitude as well as the direction here. Therefore, this is our vector quantity. And what is the direction of the dipoles? Here, as I told you, in case of the magnetic dipole, the direction was from south to north in the same way, the same concept, just the moment here. That means here the direction of the magnetic field travel directed from south to north. This is the concept of the magnetic dipole moment. And the very important in this is, just have to remember this. The small m, which represents the pole strength, is always directly proportional to the cross-sectional area. Okay? This is our small m, which represents the pole strength. It is directly proportional to the small area, and this pole strength is depending upon the nature. That means in case of the pole strength, it is directly proportional to the cross-sectional area A, and it depends upon the nature of the material. So, what I am saying is, in case of the magnetic dipole, some cases, special cases we are going to learn. So, just you have to remind this. Okay. This magnetic dipole moment. What is the unit of the magnetic dipole moment? That is what? Just a write the SI unit represents the magnetic dipole moment, and the small n which represents the pole strength. This is the magnetic dipole moment. This is our pole strength. So, what is the unit of the magnetic dipole moment? It is joule per Tesla. Teslaನು ಅನ್ಬೋದು ಅಥವಾ ಆಂಪಿಯರ್ meter square can say. And what is the unit of the pole strength? It is just an ampere meter. So this is the SI unit of the magnetic dipole moment, that is joule per Tesla, ampere meter square, and the pole strength having the unit ampere meter. This may ask in the examination. Just go through this. And this is whatever the definitions of the magnetic dipole moment. And from where to where it is directed in case of the moment is, that is from south to north. And this is our magnetic dipole moment we can define. So this is all about the magnetic dipole moment. And just you have to see that note that magnetic pole strength is depending upon the cross-sectional area of the material as well as the nature of the material. Now we shall see the special cases. Because I am continuing this special cases. In these special cases, we have case 1. Case 1. That is, first I will explain what the case 1 it tells us. If I take the bar magnet, this is our south and this is our north pole, and this it is separated by a distance, that is 2L, which is nothing but the magnetic length. Okay. So in case of this bar magnet, if I cut horizontally, that means if I cut this magnet horizontally, what happens to the magnetic dipole moment, or else what happens to the pole strength when we cut horizontally? Here the pole strength is M before cutting horizontally. Later on, before cutting horizontally, the pole strength of is M. That means normally the bar magnet, what is the pole strength of the bar magnet is M. Here also M. If I subject to cut this horizontally or along the length, in that case, what happens to the pole strength? In case of this, especially, if I cut this, okay, after cutting, see what happens here. My dear students, till now we have studied what is a magnetic dipole, what is a magnetic dipole moment, and some of the special cases of the magnetic dipole moment. Okay, so in the next class we shall learn some important terms, that is what the magnetic susceptibility, magnetic permeability, magnetic intensity, all these things we shall learn the things in the next class. This is our north. See, earlier the area was large. After cutting, it has become this much. But the length of this is remaining same. There is no change in the length. Here, two pieces we have done horizontally, therefore, two. I draw this one. This and the distance between these two. Just to observe here now. The area is large before cutting the magnet. After cutting the magnet horizontally, the area is reduced. My question is, what happens to the pole strength now? Yes. Here, as I told you in the note, here it was, that is, the pole strength was depending upon the cross-sectional area as well as depends upon the nature. Therefore, here the cross-sectional area before cutting was more. After cutting the horizontally, the area of cross-section has reduced in the bar magnet. Therefore, how I can write this one now? That is, here if I write, in case the pole strength times the L, pole strength times the Q. This is our magnetic dipole moment for this. For this also the magnetic dipole moment remains same. What happens to the pole strength? If I go here, see the magnetic pole strength for later. Okay, this is the magnetic dipole moment of this bar magnet. Okay, later on, what is the magnetic dipole moment of this two? Here, it has become the pole strength earlier was Nm, but depending upon the area now, so it has become half. Therefore, the pole strength has become half here. Okay, at the ends, the pole strength has become half. Therefore, what happens to the magnetic dipole moment now? That is m by 2 into our magnetic length 2L. Therefore, what is m into 2L? That is our magnetic dipole moment. That is m dash, I say, because the area is reduced. Because of that, the magnetic dipole moment, the pole strength is going to become the half. If I write in terms of the center, the first case, when we cut a bar magnet, this is what our case 1. That is what, when we cut a bar magnet along the length, that is what, along the length, in two equal parts, that means these two equal parts here it is, then its pole strength becomes half. That means the pole strength is going to become half because it is half. Because the pole strength is depending upon the area. Earlier the area was large, therefore the pole strength was more. Whereas after cutting horizontally, the pole strength has become to half, that is m by 2, because the area becomes the small in case of these two. Therefore, that I can write it as in terms of these two. Here m into 2L is nothing but there is a pole strength becomes half. That is what the magnetic dipole moment is going to become half when we cut horizontally. It is very important in exam. It is very important in the case of competitive like that. They will ask, if we cut the bar magnet, what happens to the pole strength? Means I have to say it is going to become the half of the pole strength, because that pole strength is depending upon the area. Here area is reduced. Because of that, it has come to half that. Okay, this is the case 1. If I talk about, so in case of the special cases, case 1 we have studied. Now the case 2, when we cut a bar magnet perpendicular to its length in two equal parts, then its pole strength remains same. This is the second case. That means if I consider a bar magnet south and this is our the north. Earlier, in the first case, what we have seen, in the first case, we have cut horizontally. In that case, the pole strength become half. But now, the case 2, if I cut this bar magnet perpendicular to the length, that means now I am cutting the bar magnet like this. In that case, what happens here? Here it becomes south and north. Okay, but what is here? The length was 12, whereas after cutting perpendicular to the bar magnet, the length has become here now. The difference you are observing here in the case of this, if I cut this, again automatically the magnets become two poles. That means, as I told you, never the magnet is going to exist the monopole. If you cut into several pieces, always that magnet is existing in a dipole. That means it is having the two poles. When I cut, what happens to the? This is M is what? Our pole strength. Here the pole strength is M itself, whereas the pole strength of another magnet is M. That means there is no effect to the pole strength when we cut perpendicular, because here the length instead of 12 it has become the L. Therefore, the case 2 is telling that when we cut a bar magnet perpendicular to its length, two equal parts, then the pole strength remains same. That means there is no change in the strength. Whatever the strength here it is, the same strength is happening here. Therefore, if we cut vertically, there is no changes in the pole strength. This is our the case. Therefore, what is the magnetic moment? Here I can write M into L. M into L. Therefore, the magnetic dipole moment of this bar magnet after cutting vertically or perpendicular to the length, in that case M is equal to M into L. This is our pole strength and this is our the magnetic length. The product of these two gives us the magnetic dipole moment. So this is what all about the special cases in case of the magnetic dipole moment. Now you understood, if the bar magnet, if we cut horizontally, what happens to the pole strength? It becomes half. If the same bar magnet, if I cut vertically or perpendicularly, in that case, what happens to the pole strength? It remains same. There is a